Hello boys and girls, this is the video that I promised I would make. Notice that these are the last 3 questions on the assignment that I gave you today in class. So let's begin. Before we actually do calculations, I need to remind you that the units of mass are in grams. So it's going to refer to mass a lot in these problems. So you need to know that when you see mass in these problems, it's going to always mean grams. Or if you see grams, it's going to always be mass. They're going to go back and forth. They're equal to each other. So mass means grams, grams means mass. Same thing. All right, so we look at the problem. You notice that we had the 51 grams down here. That's the number that you're given in the problem, and you'll need to write that number down to begin with. So you put your 51 grams of NH3 in this spot. It's important that you write both the grams and the symbol of what you're talking about. That will remind you that when you're doing formula mass, you're going to use 1 N and 3 H's. You'll remember from the beginning of the year, I repeatedly pointed out that whatever unit you see in this location will always go under the conversion ratio bar. So that would be grams of NH3 down here. So whatever is here unit-wise goes down here. Notice that I did not put any numbers in yet. There's no number here. I put moles on top. We're talking about moles of NH3. Notice that I have still not put any numbers in. After you have the units in. When? After the units are in place. So what do you do first? You put the units in place. After that's done, then you can go ahead and put your equivalency in. So 1 mole is equal to the mass of this stuff. Now to find the mass of 1 mole, you do the same procedure that we did at the beginning of class to Friday or yesterday if you were in A9, and you find the mass of magnesium. So of nitrogen. I'm going to assume that you have a periodic table, and you can see that nitrogen equals 14. 14 grams would be 1 mole. Hydrogen equals 1. Now there are 3 hydrogens in the formula, so I have to multiply that by 3. See the 3 over here? And the nitrogen, when I multiply it by the number of nitrogen atoms, that's going to be 1. So I'll end up with 14 plus 3, and that gives me a total mass of 17. Excuse me. So up here where we have 1 mole, we know that's equivalent to 17 grams. So now we're ready to do the math. You will remember from your math experience that if there's nothing here, it's like being over 1, so we're going to multiply across the top. And we have 51 on the top. We have 17 on the bottom because 1 times 17 is just 17. The grams of NH3 are going to cancel like we intended, and we'll be left with moles in our answer. So our answer is going to be 51 divided by 17, which is 3 moles of NH3. And that should be your final answer. So over here you put in 3. Now we're ready for problem number 11. Problem 11 says, ask us for the mass of 3 moles. So really we're trying to change moles into mass. But what is the unit of mass? Grams. Remember, we're going to try and find the number of grams when it asks for mass. So we take 3 moles of CS2. We know that whatever unit is here, we need to put on the bottom. So we're going to put moles of CS2 down at the bottom. Did you notice I didn't put any number in there yet? On the top, I'm going to put grams of CS2 because we're looking for mass. Did you notice that I still haven't put any numbers in? So first, you want to put the units in. All right, now we know that the number 1, I said in class, will always go with moles in this part of the course. So that's 1, and then we have to find the mass of CS2. So let's do that. So CS2, we know that C has a mass of 12. We know that sulfur has a mass of 32. However, how many sulfurs are there? There are 2 of them. There's only 1 carbon, but there are 2 sulfurs. So I have to multiply this by 2. That gives me 64 here, and I still have the 12 over here. When I add them together, I get 76. So that's the number that we put up in the top there, the number of grams in 1 mole of CS2. Now if I wanted to multiply, to do the math, I'm going to need to multiply. So I'm going to multiply across the top and then divide by the bottom. But it turns out that on the bottom, there's only ones. So really, it's just multiply across the top. So 3 times 76 is 228. Notice that moles of CS2 canceled out, just like we intended. And so we are left with grams of CS2, which is the appropriate unit for mass. All right. That was the end of number 2. So now the third and final example, we have 1,000 grams of calcium. Remember, you look at the problem first, find the number. Up here the number was 3 moles, so we wrote that down. Down here the number is 1,000 grams, so we write 1,000 grams. Is it important to say what you're talking about? Yes, so we need to put the calcium in. That reminds us that when we're doing the formula mass, we're going to look for the mass of calcium. So what do I put in first, units or numbers? I'm hoping that you said units. So you're going to put grams of calcium down here because you want them to cancel. And on the top, you're going to put moles of calcium, like that. Now our units are in, we need to put the numbers in. But what did I put in first? Oh, it was the units. Did I mention that? All right, so 1 mole of calcium, we always put 1 with moles, is equal to 40 grams. And we know that by looking on the periodic table. And since it's only calcium, we don't have to add anything, it's just 40 grams. So now we have 1,000 divided by, well, let's talk about the math. This is 1, being over 1. So now you got 1,000 on top, you've got 40 on the bottom. So really, in this ratio, you can shortcut a little bit by just thinking, well, if this number, the big number's on, if this number's on the bottom, the 40's on the bottom, you're going to divide by it. But if the 40's on the top, you multiply by it. In this case, it's on the bottom, so you're going to divide. So 1,000 divided by 40 is 25. That'd be 25 what? Well, look, grams cancel. Oops. So grams cancel. So what we're left with is moles of calcium. So our final answer here would be 25. I didn't write the final answer up here, it would be 228. Now in all 3 cases, what we really did was multiply by 1. Because 1 mole is 40 grams, we could say that they're equal to each other, therefore they're 1. So you're really setting up a ratio equivalent to 1. Same thing here. 76 grams is 1 mole. And up here, 1 mole is 17 grams. So in all 3 of these cases, they contain 1 mole, but the masses are different. But that's no big surprise because with the analogy we did in class, we know that a dozen elephants had a different mass than a dozen cats, but they're still both a dozen. So, I think that's all I need to say about these problems. I hope that helped. And you need to have these done by as soon as you can, next class. Thanks.